Hey everyone, how goes it? And welcome back to Computer Science 145. Today, we're going to discuss inheritance and polymorphism. In previous lectures, we've been discussing code organization. Along with this, we've been introducing these concepts called object-oriented programming. One of the major concepts of object-oriented programming that we've gone over is called encapsulation, in other words, information hiding. Now we're going to discuss the other two principles of object-oriented programming, inheritance and polymorphism. Inheritance allows data and methods to be inherited, to be absorbed from one class to another. Now in Java, this occurs between two classes. You have what's called the subclass, or the child, and this is the class that is inheriting from another. You also have the superclass, the parent, and this is the class that is being inherited. Now, in a lot of ways, this does work like biological inheritance, where you inherit properties from your parents. Now, this concept is great for extending the properties and functionality from one class into another. The best way to think about this is the subclass becomes a more specific version of the superclass, and the superclass is a more general version of the subclass. This also creates what's called an is-a relationship. So the child is a more specific version of the parent. Private properties and methods are not inherited from the superclass. However, they can still be used. Instance variables from the superclass have to be accessed through their accessors, and also instance variables can be modified in the superclass via their mutators. Now, in order to start using inheritance, the reserved word extends is used to inherit from one class into another. So for instance, inside of the class definition, you have public class and then the subclass's identifier. Then you have this reserved word extends followed by the superclass's identifier, and this creates the subclass is a more specific version of the superclass. Now also, there is a reserved word called super that is used to call methods from the superclass. This is going to be explored a lot in this lecture, but keep this in mind. In order to call the superclass's constructor, it should be super followed immediately by the parenthesis. Then, if you want to call the superclass's methods, then you would use super dot followed by the method ID and its parameters. So for instance, if you needed to access the properties from the superclass, you would use super dot and then a call to the accessor. Or if you wanted to modify the properties, then you would use super dot and then a call to the mutator. Now, very importantly, in Java, a subclass does not inherit constructors from the superclass. The reserved word super should be used to call the superclass's constructor, and this generally should be the first call in a subclass's constructor. Make sure to do this so you can avoid errors. Now notice right here, what you would use inside of this constructor, it still works the same way. Public, no return type, and then you have the subclass's ID. And this is the default constructor as we have no parameters. But notice right here, you call super followed immediately by the parenthesis, and this is a call to the superclass's default constructor. Now with our running example, that's going to be explained in a lot more detail. If we have the student, which was established that a student is a person, then its default constructor public student is like this, and then we call super with the parenthesis, and this is a call to the person's default constructor. Now very similarly, you have the parameterized constructor, and this one also follows public, no return type, and the subclass's ID. Something that is very different about this one is, instead of creating a parameter for each one of the instance variables in the subclass, you need to also include the superclass's parameters. So notice, inside the parenthesis, we don't just include the subclass's parameters, we also include all the superclass's parameters as well. The reason why we do that is so we can call the superclass's parameterized constructor. That way, the properties can be set inside the superclass, and then the subclass's parameters can be set inside of here. Now let's just assume in our running example that the person has only one instance variable, and that's their name. And also the student has only one instance variable, a student ID. Notice that the parameterized constructor includes both the name that is found in the person and also the ID that's found in the student. In this way, we can call the person's parameterized constructor, pass this information so it can be set inside of there. This is very important to keep in mind, but when you are inheriting from one class to another, a subclass does not inherit the constructors from the superclass, and in fact, we need to be able to call those constructors from the subclass's constructors. Now, let's discuss overriding methods. Overriding methods is when a subclass has the exact same signature or definition as the method in the superclass. Now, this is different from overloading methods. In a previous lecture, we discussed overloading methods where a method had the exact same signature but different parameters within the same class. Overriding methods is when you have the exact same definition or signature in the subclass that appears in the superclass. What this does is it overrides the superclass's version. Now, along with that, it can be very useful to call the superclass's version by using super followed by the method ID. Now, this can be seen when you're overriding the equals and the toString method. So the way that you can utilize this in the toString method is you create the toString method in the exact same way that you did before. The only difference is you call super.toString, and this appends the string returned from the superclass with the other properties that you add here. Now, continuing with our running example of the student and the person. If this is inside the students, and this is the student's toString method, then if we call return super.toString, this calls person's toString method, appends that to the ID and the ID found in the student. Now also with the equals method, it starts out with public boolean equals, and then you have another instance. The way that we can utilize this is then we return super.equals, which calls the equals method from the superclass, and give it that other instance to check these properties that are found in the superclass. Then you AND that with the other property checks. So again, with the student and person example, if we have the student's equals method, notice this. Public boolean equals, and we have student, a student. We first check if it's not null, and then we call super.equals, a student. Now this checks the properties that are found both in student and person, but inside the superclass. So it only checks the properties found inside the person. Then we just AND that together with the check this.id is equal to the accessor, another student.getID. And if all of this is true, including the properties that were found in the person, then it's true. Now also, the reserved word final can be used so that a method cannot be overridden or extended. Now with all of these concepts introduced, we can better see this through an example. So let's first establish the problem. Let's say that we were contracted to create a personnel system for a university. We need to keep track of important information about people at the university. And the different types of people include undergraduate students, graduate students, faculty, and staff. Now for the undergraduate students, we need to keep track of the name, student ID, and their level, which would mean freshman, sophomore, junior, and senior. Graduate students need to keep track of the name, ID, and their advisor's name. And you can basically think of their advisor as being their boss. Faculty, we need to keep track of name, salary, and the courses that they are instructing. Staff information would include their name, salary, and their supervisor. And also, what we require this system is it should be able to add new people, remove people, and view all the people in the system. And it should also include a clear and easy to use front end. Now that we understand the problem and we have our requirements, let's start designing the software. Let's start establishing the very first noun that we noticed. An undergraduate, or we'll call it UGrad for short. Now what were the properties we should keep track of for an undergraduate? Well, their name, their ID, and their level. What are some of the actions that should be included inside this class? To keep this simple, let's just include toString and .equals. So that's our first noun. So we created a classification, a class, called undergraduate. That way we can create more instances of these undergraduates. But that was not the only one, because there was another noun that was a graduate student. Now for a graduate student, we had to keep track of their name, their ID, and their advisor, and let's just keep it simple and say their methods should simply be toString and equals. Now I'm starting to notice this as I'm designing. The undergraduate has a name and ID, and the graduate student also has a name and an ID. Now these two properties are pretty much the same thing, which would also mean that for the undergraduate and the graduate, I would have to create accessors and mutators that are basically the exact same for this one class and this other class. But these effectively could be shared properties. These effectively could be inherited for a more general version of an undergraduate student and a graduate student. Well, what could be a more general version of these? A student. So let's say that this student class has the properties name and ID, and also the methods toString and equals. What I can then do is establish the inheritance relationship between undergraduate and student, and graduate and student, just like this. Notice that this is a different type of arrow in this UML class diagram. It's a block arrow. In a UML class diagram, the block arrow indicates inheritance, or it's referred to as the is-a or extends relationship. So think of it this way: undergraduate is a student, and graduate is a student. And now, because they are inheriting the properties name and ID from this class, we can remove those properties from ugrad and grad. Because effectively, we have absorbed the properties inside of here, and we can access and mutate them by calling the superclasses, the student classes, name and ID methods. Now, as I continue designing this, I recognize that we have to create a faculty and staff, and look, they have the shared properties of salary and name. So now a faculty member is an employee, and a staff member is an employee. But wait a second, I'm noticing the property name and name right here. These are also shared. So is there a more general version of a student and an employee? Well, let's just say that that is a person. Now, as the person has this string, and as the student is a person, the student has a name and an ID. And as an undergraduate, it has a level, but as it is a student, it has an ID, and as it is a person, it has a name. Now, in order to finish this design, what I have to do is create a personnel manager that has a collection of people with the functionality add, remove, and print. And then we need a clear and simple front end, like this personnel manager front end, which will have an instance of the personnel manager with the main method, and then the functionality to add, remove, and print everything out. However, in order to keep this very simple, let's just look at this branch over here. Let's look at person, student, and undergraduate, or just like this. And then let's just create a very simple tester to test all of this out. So this is what we're going to be creating. Now, let's get to the code. So as you can see, we have our project set up and ready to go. Now, what we need to do is create the first class. Well, I noticed that all of my arrows seem to be pointing at person, so that should be the first class that we create. And we're going to do this in the exact same way that we created a class before by following those 7 easy steps. So first, we're going to define the class, and this class is called person. I'm going to put my name at the top here. Now, according to my description, person only has one instance variable. private string name. Then we create our constructors, public person, and let's just assign this dot name is none, just at first. Then we have our parameterized constructor, public person. Then we have string an for a name. And then to do call mutator. Then we create our accessors, and well, we only need to create one. Public string get name. Side of here, return this dot name, so we can return this instance's name. Then we create a mutator, public void set name, string an. Now, as a string is a class type, we need to verify if this parameter even exists. If an is not equal to null, we consider this to be correct, and we'll set this dot name is equal to an. But otherwise, we'll set this dot name is equal to, let's just say none, because that was the default value. Now, back in our parameterized constructor, we call this dot set name an to make sure we do all that. Next, let's create the toString and dot equals method. Public string toString. Now, I'm going to return, and just to make this nice, I'm going to start with the string name, and then I'm just going to append the property this dot name. Then we need to create the dot equals method. Public boolean equals. Now, we need another instance that we're comparing this person to. So person AP, do they have the same name? So then we just return. First, we need to check if this person even exists. So AP is not equal to null. And if that's not equal to null, then we can check this dot name. Now, as this is a string, we need to call dot equals. And then we need to get the other person's name by using the accessor, ap.getName. So if this other person exists, if it's not equal to null, and this name is equal to this other person's name, then we consider that to be true. So now we've created the class person, let's create a more specific version of a person that is a student. So first, we define the class, public class student. The next thing that we need to do is extend person. And now this establishes that inheritance relationship, that student is a person. And now we have inherited the properties, the name from the person. What makes a student a more specific version of a person in our system? Well, we have a private int ID. All students have a student ID, but not all people have a student ID. So again, the student is a more specific version of a person, and a person is a more general version of a student. So now we get to constructors. We start out the exact same way. Public student, and let's start with the default constructor. The first thing that we should do is call person's default constructor, so we'll call super with the parenthesis. And remember, this is the person's default constructor. Now, just like any other default constructor, we need to set our properties to some default value, so I'm going to set this.id is equal to 0. Now the more complicated version, the parameterized constructor. It starts off in the same way. Public student. Now what we have to consider is what is the properties that are also included inside a person, not just what's inside a student. Inside a person, we have the string name. So as this is a parameterized constructor, we need to include all of the properties as a parameter. So this means we need to include string an because person has the name, and also int and ID for the student's ID. From here, we can then call person's parameterized constructor by passing an into there. Now again, this is person's param constructor. And then I'll put to do call mutator. We'll get to that in a minute. Now with inheritance, accessors and mutators, they don't change. Public int get ID, return this.id, public void set ID, int an ID, and if an ID is greater than or equal to 0, then we consider it to be valid. So this.id is equal to the parameter an ID. Otherwise, this.id is set to 0, the default value. Now that we've written the mutator, let's make sure that we call this.setID with an ID. So now we get to the other two methods, toString and .equals. ToString starts out the same way. Public string toString. Now what we're going to do is return. However, in order to include the properties that were found inside the person, what we can do is utilize the person's toString method. So I'm going to return super.toString. Now this calls person's toString method, which this returns the name concatenated together with the property name. And then I'm going to concatenate that with ID with the property this.id. Then we get to the .equals method. Public boolean equals student as, another student. Now I'm going to start out return as is not equal to null. This is always a good check to start with. And then what I'm going to do is AND that together, because here's the thing. I need to check the other student's ID, but I also need to check the other student's name. Well, that can be used by utilizing the person's equals method. So I can call super.equals as. And as we know, whenever we call this method and we pass in this instance, it goes here, checks the name, and if the name is equal, this would return true, but then we have to check this.id is equal to another student.get their ID. So now, if a student is not null, and their names match, and their IDs match, then it will all return true. Now that we've written these two, let's actually see how these can work. I'm going to go ahead and create the tester. This is just going to have the main method. Now I'm going to create a person with the default constructor and a student with the default constructor. Then system.out.println, let's print out P. And system.out.println, let's print out S. Well, notice this. When we constructed the person, when we pass this in, this calls its toString method. And this returned name plus the name, which default is none. Then when we constructed the default student, we had the default constructor of a person, which was none, but it also appended together the ID from the student. Now let's continue this by creating an undergraduate student. So once again, we start out by defining the class. Now an undergraduate is a student. So we can say ugrad extends student. So this means ugrad absorbed all the properties found inside a student, which was the ID. And because student is a person, it also inherited all of the properties inside a person, the name. So the undergraduate has a name, an ID, and also private int a level. And let's just say for argument's sake that we just use the integer values 1 for freshman, 2 for sophomore, 3 for junior, 4 for senior. Now let's just create the constructors. Public ugrad. Our default constructor needs to call student's default constructor. And also, let's just set this .level to a valid value, which will be 1. But most importantly, notice this. This is a call to student's default constructor. when this is first called, it calls the student's default constructor, that calls person's default constructor, that assigns the name to none, that assigns the ID to 0, and then we assign the level to 1. Now the parameterized constructor, public ugrad. Now this one is a little more complicated because we need to include all the properties that have been inherited. So we know that person had a name. We also know that student had an ID. And now this we have to have a level. So we included all of the different properties found in person, student, and now the property we have to set, which is a level. Now what I can do is call student's parameterized constructor. So super a name with an ID. To do call mutator. And we'll get to that in a minute. But most importantly, the properties a name and an ID are passed to student, which the name is then passed to person. Then the person sets the name, student sets the ID, and then the undergraduate will set the level. Now we create accessors and mutators. They don't change. Public int get level. And we can return this dot level. And also public void set level int al. Now we need to validate if al is correct, if al is greater than or equal to 1, and al is less than or equal to 4. Then this dot level is equal to al. Otherwise, we set it to the default valid value of 1. Then inside of here, we set this dot set level. Now let's go ahead and write the toString and dot equals method. Public string toString. Now just like before, I want to include all the properties that were also found in student and also inside a person. So I'm going to start return, but where I'm going to first begin is I'm going to return super.toString. So this calls the method toString from student, which calls the method toString from person that returns the name with the name property, the ID with the ID property, and then all I have to do is just to append level with this dot level. And we're done. Equals is very similar too. Public boolean equals, and this time we need an instance of a ugrad, so we'll say AU. We're going to first return, it's always a good check to check whether or not that parameter is null. So if it's not equal to null, and then, well, wait a second, we have to check this other undergraduate's name and ID. Well, that can simply be done by calling super.equals undergraduate. So this one calls students equals method that calls persons equals method. So the persons equal method would check if this other undergraduate's name is equal. The student would check if the ID is equal. And now all we need to check is if this dot level is equal to an undergraduate's get level. So now we've created an undergraduate, which is a student, and a student, which is a person. Undergraduate inherited all of the properties in the methods from student, and student inherited all the properties and methods from person. Now to show this, I'm now going to create ugrad, u is equal to new ugrad. Let's just use the default constructor, and now let's see this, system.out.println u. Now as we use the default constructor, the person's name was none, the student's ID was set to 0, and the undergraduate's level was set to 1. But by doing this, we were able to both construct a person, a student, and an undergraduate very simply. Now there was something very subtle that you may have noticed, and I want to bring this to your attention right now. Let's take a look at the equals methods in more detail. First of all, let's notice this. Public boolean equals undergraduate and undergraduate. Well, here's the thing. We call super.equals passing in an instance of an undergraduate to the student's equals method. But wait a second, this parameter's type is student. Why is there not a syntax error right here? Because this is a different type. ugrad is a different type from student. Well, as an undergraduate is a student, we can substitute this undergraduate for the type student. And right here, we call super.equals a student. This is expecting the type person. And as student is a person, we can substitute the type student for the person. Now, this is a very strange and difficult concept called polymorphism. Now, before we get to that, there's one other detail I want to explain. Inside of Java, everything extends from the object type. Now, this is why every single class is assumed to already have a toString and equals method. When we write the toString and equals method, what we are doing is overriding object's toString and equals method. Whenever we call system.out.println, this calls that object, that class's toString method. Whenever we override it, we make a more specific version of that. If we do not write the toString method, what it ends up printing out is generally the class's name followed by a memory address. This is why it's a good idea to override those. Now, polymorphism is the concept of one becoming many. The superclass can be extended or implemented in many different ways. A change to the superclass is reflected across all classes, and this also allows substitution of one class for another as long as it is an extension. Now, this is exactly how that equals method works, and this is all made possible by dynamic binding, otherwise known as late binding. Now, the most powerful element of this is notice. If we were to make a change in the class person, let's just say not just the name, but maybe each person also needed an address or an emergency contact number. If we made a change to this class, then all of the classes that inherited from person would also have those properties. This makes our code extremely flexible. That way we can extend, we can add new functionality very easily. Now, before we leave off, let me show one other thing about this. Polymorphism is very powerful, and basically, you can substitute one class for another as long as it extends that other class. So let's create a person array. Let's just call it people, and this will be a new person array, and let's just say it's just 3 people. Now, watch what I can do with this. People at index 0. So the first person inside this array, I'm going to construct this as a new person, and let's just say their name ASDF. Something very simple like that. But then I can create people at index 1 and construct a new instance of a student. ASDF2, and let's say their student ID is 4. And also, people at index 2, I can create a new ugrad. Their name ASDF3. ID is 5, and their level is 2. So then, for int I is equal to 0, I is less than people dot length I++. System.out.println people at index I. Watch what happens. As the first instance was a person, they only had the property name. As the next one was a student, it had a name and ID. And as the next one was an undergraduate, it had a name, an ID, and a level. However, we were able to use one collection of this super type person and have more specific versions of these people inside of the same collection. Inheritance and polymorphism is a very powerful technique, and it allows our code to become even more flexible. That way, we can modify and extend functionality in our software. We're going to explore this more later on, but until then, I'll see you next time.